each other. Now let's go over these two expressions. Alright, so we have expression 1, n squared minus 9 divided by 2 times 4 minus 3. And we also have n plus 3 times n minus 3 divided by 8 minus 3 times 2. So we got two different expressions there, and we looked at n is equal to 5. When n equals 5, group 1, what did y'all get for the value of your expression? Yeah. 8. Did anybody get a different answer other than 8 for the first expression there? We all got that? Yes? Okay. I need to point this out though. Nope, not for the. Oh, this is something I do want to point out. I saw a lot of us for this problem, and it's perfectly acceptable. It is correct. Where they did 2 times 4 and 2 times negative 3. Josh, what property are the people who are doing this 2 times 4 and 2 times negative 3? What property are they using? So for, I know this is not the expression you had, but I do need you to pay attention and maybe take some notes. But those who had expression 1, the odd groups, a lot of them took 2 and they multiplied it by 4, and then they took 2 and they multiplied it by negative 3. What property is that? Starts with a D.
Distributive.
Distributive property.
Property.
That is a valid property in mathematics. Is that the easiest way to do this one though?
Yeah.
No, what could I have done instead?
I don't know what it is.
Remember, can you just do the parentheses first?
Yes.
Yeah. You don't have to actually. You can distribute. What is 4 minus 3? 1. And what's 2 times 1? 2. But what's 2 times 4?
8.
And 2 times minus 3? So 8 minus 6. And what is 8 minus 6?
2.
So did you have to do the parentheses first? No. The distributive property is actually a great property when variables are involved.
Yeah.
You don't need to distribute here. I would just do 4 minus 3. That's way easier. But you know that distributive property because you started working with variables. So please be aware of that. Okay, so think about that. Someone in, I guess, group 2. Group 2, what did y'all get when n equals 5 for that second expression? 8 again? Huh. Interesting. Those are different expressions, but we're getting the same value. Hold on. N equals 7. Group 4. What value did you get when n equals 7 for the second expression here? You got negative 1 here? So when n equals 7, what did y'all get for the second expression?
I got negative 1.
Negative 1? Did anybody get anything different? The rest of us did get something different. So let's look at this one. What did you do, Claire, to get started on this problem? You don't pay attention. Sorry.
3 times 2.
Okay. So you did 8 minus 6. There was nothing you did before that?
7 plus 3.
Okay, so you substitute that 7. So 7 plus 3 times.
7 minus 3.
There we go, right? And so from there, you did that multiplication first. Okay, so what did you do next?
I did 7 plus 3.
Which is
10.
times
4.
4. So 2 times 4 divided by,
8 minus 6.
which is,
Negative 1.
what's 8 minus 6?
Oh, wait. 2.
So you had all this right. Be careful, right? One small thing can make a mistake, and I was wondering where that happened. So what would we do from here?
10 times 4 divided by 2, which is 20.
So 40 divided by 2, which is, you good with that, Claire? So you had most of the ideas right, and that's why I always want to go back through these to see where those mistakes were. And this is important, y'all. small mistakes can mean that you get a completely wrong answer, but does that mean you have no idea of what's going on? No. This is why we need to learn from our mistakes. It's hard to learn from our mistakes though when we're flicking around a little bobby pin or whatever that is.
Yeah, Gabe.
Pick up a pencil and take some notes.
Ugh.
Pay attention. So, did everyone get 20 here?
Yeah.
Yes?
Yeah.
Group 3, what did y'all get when n equals 7 for this first expression?
What you get?
You also got 20? Did anybody get anything other than 20 for that first expression? Huh? They're like the same.
It's gonna be different.
So n equals 13. Group 5. What did y'all get for n equals 13? 80? Did anyone get something other than 80 when n equals 13? No? Group? What did y'all get? You got 82 over there? Group 6, y'all agree that it was 80 here?
Yeah, we got 80. Well, they got 80. That's what Huh?
I want us to pay attention. We're going to have to talk about the -1, but I need you to pay attention to something. Do these expressions look the same?
No,
They look very different, don't they? Yeah. Close.
I mean,
Okay.
they're different expressions, but they all got the same answer or whatever.
Okay, so they look different, but those expressions must be the same. So what do you think we call that? Equivalent.
Yeah.
So, before we talk about the n equals -1, this is where you definitely need to take a note. I don't have an answer.
No, this is you should answer.
Hold on, hold on, hold on,
It's about that.
hold on.
Alright.
Okay?
You man.
Stop worrying about what time it is and focus on your learning. Thank you. Yes, Dee Dee.
Okay, so basically, equivalent is like another one. It could be the same answer, but like there could be different expressions or whatever, but they'll still have the same answer.
The most efficient way, because it'll apply in lots of different situations, is to say that equivalent concepts, they look different,
But have the same answer.
but they have not the same answer, but they are the same in some way.
Okay.
Okay? So looking at equivalent expressions, what we would say is, these are expressions, and this is where I would take a note because we're defining a key word here. These expressions look different, but are effectively the same. Notice that language that Dee Dee just used there, and that's the whole point of the way I teach. You just what? Does anyone know what Dee Dee just said? I just realized that.
Yeah, I just realized.
Did I lecture that to her?
No.
Is that something that all of us started to see a pattern for? Because math is a language built on patterns. You are capable of discovering patterns. This is why every single one of you can be very successful in mathematics, no matter what your past has been like. Okay? They look different, but are effectively the same. The inputs have the same outputs. Or let's say each input
Each input.
has the same output. All right. Let's see here. Group 2. What did y'all get when n equals -1? -4. N equals -1. Jalen, did you get -4 when you worked this problem out for the first expression?
The second time.
The second time, but not originally?
Yeah.
How many of us got -5 if we had this first expression? Okay, hold on a second. -10. We're going to talk about it, but I need us to discuss this because this is an important detail. Notice it's much easier to see with the second expression. -1 plus 3 times -1 minus 3 divided by 8 minus 3 times 2. That gives me 2 times -4 divided by 2, which gives me negative 8 divided by 2,
Oh, I got 5.
which is
Okay.
negative 4.
Okay.
Notice that's a negative 4.
Yes.
And these expressions are what?
The same? What?
Oh.
There we go. Say it again. Equivalent. They look different, but they're you were saying the same, right?
Equivalent.
They are equivalent. So what should we have right here?
An equivalent
Wow,
of
smart.
So we need a negative 4. Ladies and gentlemen, when we look at n squared minus 9, everyone should write this down. I don't care which expression you're working with. Everyone should write this down because this is important.
Okay.
You have n squared minus 9, and then divided by 2 times 4 minus 3.
Right there. Right there.
Write this. And we are looking at n equals negative 1.
Okay.
Notice the entire n is being squared, correct?
Yeah. Yes.
Yes.
N is being squared. And what am I substituting in for n?
Negative 1.
So I have negative 1 squared minus 9 divided by 2 times 4 minus 3. But right now, is that negative 1, the entire negative 1 being squared?
No.
No. The calculator understands the correct order of operations. The negative 1 is not being squared. What would I need to do to make sure the entire negative 1 is being squared? Parentheses. For those of us that got negative 5, let's look at it again when we correctly do negative 1 squared. So what is negative 1 squared? It's 1. It's 1. Remember, yeah, positive 1. Because what does it mean to square something?
To like add it.
Not added.
Repeatedly.
Repeatedly multiply. Kaisen, I need you to pay attention because you were confused about this earlier. Okay? Remember, when you square something, that's not repeated addition, that is repeated multiplication. So that is literally negative 1 times negative 1. And what's a negative times a negative?
A positive.
A positive. That's why it's a positive 1 here.
Okay.
And 4 minus 3 is 1. So I get 1 minus 9 is negative 8. Divided by 2 is negative 4. Notice, using the first expression, I correctly get negative 4. And Jeremy, don't just listen to Jalen. You had it right from the beginning. Trust yourself. Talk it up. Alright? So, 2 things I want to point out. Did you perfectly understand what to do?
Yes.
Yes.
Oh.
So not at first, but then when I caught on to it, then yeah.
Okay, so let me clarify this. Okay? Did at least one person in your group know what to do? Every group had at least one person who knew what to do. That's why you have a group, because you may miss details. You may be sleeping. You may not want to work, right? But there's somebody in your group who can help you out. Talk with your group while I'm talking to other groups. However, did we already know what equivalent expressions even meant?
No.
Not really. Did you have some idea? Yes? Okay, listen. You did not know the idea I was trying to teach you. I gave you a task to do that you could do. You could substitute those values and figure out what's going on. And then, you see how we're having a whole class discussion about it so that we can start to see patterns and put language to that pattern? This is how the class should work. I'm not going to directly lecture to you most of the time. Okay? It is very rare when I'm going to give you the information you need ahead of time because that doesn't get you to think. If I just lecture to you, all I'm doing is telling you exactly what to do. One, that's boring as crap. That's when I get people falling asleep. When you're talking with a group, there's no excuse to fall asleep. But when you talk with a group and you explore and you make sense out of this should have helped some of us practice simplifying expressions, didn't it? So it helped us develop our understanding of a previous skill and we discovered something new. This is how we learn. You need to make sure you understand what an equivalent expression is. With the last 15 minutes that we have, here's what we're going to do. We're going to go beyond equivalent expressions. And we're going to start getting into equivalent equations. Okay? just as a prediction, listen up. To get us started on this, based on what we talked about with equivalent expressions, does anyone have a prediction of what an equivalent equation might be? Dee Dee, you figured it out with equivalent expressions, so hold on. Anyone have an idea what we might mean by equivalent equations? What you got, Jalen?
So, you got like two problems, right? And you gotta make them give the same answer on both sides.
So when you say two problems, what do you mean?
Two equations.
So two equations that might have the same answer? What's the answer to an equation? It's not the most precise language. Okay, so, no, what was it again?
Solution.
Solution, right? So when we have two different equations that might have the same solution, another way to think about it is it's two different equations that might tell the same story. And the reason I bring that up is because of these contexts right here. Write as many equations as possible that could represent the relationship between the ages of the two children in each family described. Be prepared to explain what each part of your equation means. There are lots of ways to write each of these equations. Now, I want to point this out. You see right here where it says A?
Yep.
You see how that says family A?
Yes.
Okay. You see right here in B? It
Yes.
says family B?
Oh, so they got a family?
Are they the same family?
No.
No. So, please hear me very clearly on this. What you do in A should not impact what you do in B. None of the numbers in A are numbers in B. Is that clear?
Yes.
Okay. The next thing I want to point out is this. Alright? If I were to say X is 7, that word is would translate to what mathematical symbol? Equals, right? X is 7. X equals 7. That should be a good hint to help us get started on developing some equations for A and B. When we hear that word is, or we hear that something is similar, the same as something else, we should be thinking about equals to. So, let's get to work. You can think on your own for a little bit, and work on your own, in fact, but before you move from one problem to the next, what should you do? Talk about it with your group. You should not move on without your group. You need to check in on everybody because you are responsible for each other's learning. If you are stuck, what should you do? Ask people within your group. If no one has an idea, I'll be coming around trying to get to you. But let's get to work. We got 15 minutes.
But Mr. Kennedy, it's the same child.
Say again,
It's
sir?
the same child.